Today we're going to work on 2.0. And this should all be review from last year. You're going to be doing things like multiplying a number into a binomial. So that would be 12x plus 24. Easy enough, right? Yes? Easy enough if you know your multiplication table. Thank you. Okay. What if I had x plus 4 times 2x minus 1? So you can multiply like this. Okay. I like to use this multiplication box because it helps us with factoring and it also helps us with something else this year. So you don't have to use it, but it is valuable to know how it works. So each square is just the product of the row and column that it resides in. So this would be 2x to the third, 8x, negative x, and negative 4. It's not the third, it's squared. Jeez, guys. Oh, this is going to be a good day. All right, let's see if I can do it right from now on. 2x squared. These two are like terms, so they go together. 7x and negative 4. Okay. Everybody understands that? All right. Let's take a look at our assignment today. Okay. Oh, really? Why is it out of order like that? Huh. So here we're going to multiply 7c to the third into those. Can you guys change the order of these? Like, can you do them out of order? Yeah? Okay. Because anyway, it doesn't really matter, but they're not in the order that I put them in, which I don't know why that's the case. All right. What if we had something like this, y minus 5 squared? Can we just say y squared plus 25? Well, you can, but you'd be wrong. So in this case, we need to write it out y minus 5 and y minus 5, y squared minus 5y minus 5y plus 25. Those two go together. Y squared minus 10y plus 25. Okay. Everybody understand that okay? All right. What about factoring? What if I had x squared minus, let's do 4x to the third plus 6x squared plus 10x. Is there anything I can factor out of that? A 2 and an x. So everything is divisible by 2 and everything is divisible by x. So I'm going to yank out a 2 and an x, and that would leave me with 2x squared plus 3x plus 5. And then that may or may not factor. It probably doesn't because I just made it up. All right. Are you guys okay with factoring out something from a polynomial? Okay. What about x squared minus 6x plus 5? I don't know what I did. I killed it. Huh. We're back. We're back. So I want to factor this into 2 parentheses. This number is positive. What does that tell me about the factors? They're the same sign. So it's x minus something and x minus something, or x plus something and x plus something. How do I know which is which? The middle sign is negative, which means both of these have to be negative. Now, are there factors of 5 that add to be 6? Negative 6. Yes. 5 and 1. Well, these are called factors. What if I asked you to solve or to find the roots? Then you just write equals 0 on each of those. And then we add 5. So x is 5, and add 1, x would be 1. What do these numbers tell us? That's where the graph crosses the x-axis. Okay. Those are the only two numbers you can plug into the original equation and get 0. Now let's do. No, I like that. Okay. So we try to factor that. This is a negative. What does that mean? The signs are opposite. One is positive, one is negative. And what does this tell us? The bigger one's negative, because when those two forces fight each other, one's positive and one's negative, the bigger of the two is going to win. And the middle number ended up being negative, so the bigger of the two has to be negative. So x minus 6 and x plus 1. Okay. Everybody remember how to do that? Okay, what if I have something like sometimes it's valuable to break this 48 down into its factor pairs. So I write 48 over here. What multiplies to be 48? Well, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 doesn't work, 6 and 8. Can I build a negative 2 with any of those factor pairs? 6 and 8. So x minus 8 and x plus 6. Okay. All right. What if we had x squared minus 4x? How would you solve that? Well, what do they share? An x. So we pull out an x and we have an x minus 4. So we set each of those equal to 0. X would be 4 and 0. Okay. All right. What if I had how would you solve this? Take the square root. So x plus 1 is equal to, oh, don't forget the rule, plus or minus 3. Why is that? If I have something to the second power equals 9, then 3 works, but negative 3 also works. So anytime you square root an x squared, you need a plus or minus. What if you take the third root of x squared? Do you need a plus or minus? No. What about a fourth root? Yes. So anytime the exponent is even, you would need a plus or minus. Okay? So we subtract 1. And 3 minus 1 is 2. And negative 3 minus 1 is negative 4. So 2 and negative 4 would be the answer. Okay. All right, what about this? How does that factor? Can I square root it? Because x squared and 16 are both perfect squares. No. For the same reason that I can't do this for that problem. right? We have to take into account the middle term. So what is the middle term here? So it's really x squared plus 0x minus 16. Can you think of two numbers that multiply to be negative 16 and add to be 0? 4 and negative 4. So x minus 4 and x plus 4. So your roots would be 4 and negative 4. Okay. What about what would the factors be? Would 5 and negative 5 work? No, why not? Yeah, if there was 5 and negative 5, the 25 would be negative. So what if we tried 5 and 5? They don't add to 0. What if we tried negative 5 and negative 5? They don't add to 0, so this one actually doesn't work. It doesn't factor because of the negative, or because of the positive. Okay. What about how would that factor? So 3x minus 7 and 3x plus 7. What would the roots be? If I wrote equals 0, we would add 7 and divide by 3, and then subtract 7 and divide by 3, like that. Okay? All right. These are a little bit harder to do in your head. Let me find one. Okay. This one I'm going to need a little bit extra to factor it. Because this number is not a 1, it's probably not something you can do in your head. So here's what I recommend. You draw the box, and you put this in the box. 3z squared. Then you stick this in the box. Okay? And then you multiply those together. 3z squared and negative 2 makes negative 6z squared. And then you use that to find your factor pairs, which would be 1 and 6 and 2 and 3. And now I'm trying to build a positive 1. Can I build a positive 1 with one of those sets? 2 or negative 2 and 3. So this box would be 2z, and this box would be negative 3z. Oh, did I get that wrong? Thank you. Okay. Now look at the top row. What does the top row have in common? A z. So I'm going to pull out a z. And then I'm going to use that z to fill in all the other blank spaces. If I take a z out of this first one, I'm left with 3z. If I take a z out of the second one, I'm left with negative 2. And then we look in the first column. If I take a 3 and a z out of the first column, I'm left with z and 1. So my factors would be 3z minus 2 and z plus 1. What would the roots be? 2/3 and negative 1. Okay, is this how you guys learned it? Kind of? Long time ago? Do you guys want to see another one of those? Yeah? Okay. Um, oh man. Oh, will it give me another problem if I do that? No. Oh, thank you guys. Awesome. Okay. Draw the box. Put in the first one and the last one. Oh, can I take anything out? No. Sometimes you might need to take something out and then factor it, but not in this case. So 5x squared and 15. 5 times 15 is 75. So 75x squared. 1 and 75, 3 and 25, 5 and 15. Will one of those sets give me a positive 28? 3 and 25. So 3x and 25x. The top row shares an x, and then I'm going to use that x to fill in all the other spaces. Here's what you don't want to do. You don't want to say the top row has an x, and the bottom row has a 5, and the first column has a 5 and an x, and the last column has a 3. Sometimes that works, but sometimes it doesn't quite work the way you want it to. So look at this row here and pull out an x, and then use that x to build everything else. If all you do is look for common factors, every once in a while you're going to get the wrong answer. So if I take out an x, I'm left with 5x plus 3. And if I take out a 5x, I'm left with 5. So my roots, well, the factors are 5x plus 3 and x plus 5. If it asks you to find the solutions, negative 3/5 and negative 5. Okay? All right. The last problem type is complete the square. Oh, really? Oh, geez. Nope, I'm going to take that off. That's dumb. We'll have to do complete the square a different day. Okay, that's it. Get to work.